I can't wait for summer.
What's up, Oliver?
I'm organizing last year's photos. Looking at the pictures I took during summer, I'm starting to miss it.
Indeed, summer has long vacations and plenty of leisure activities like the beach and mountains. It's fun, isn't it?
Is that so? I particularly love the ocean. I'm really looking forward to swimming and playing watermelon smashing. By the way, I was thinking when we spin our bodies during watermelon smashing, our eyes get dizzy, right? I wonder how that works. It's really intriguing when we think about it.
That's an interesting perspective on how our eyes get dizzy. If you'd like, I can explain it to you.
I'm counting on you.
So for this time, I'll be explaining how dizziness works. Oliver, what do you think it feels like to be dizzy?
I think it's a state where you can't stand properly because your sense of balance is off.
That's generally correct. When you're feeling dizzy, it means there's an error in the parts of your body that are responsible for balance. Here's another question. Which part of the body do you think detects balance, like our sense of equilibrium?
When you put it that way, I have no idea.
Actually, it's your ears that sense balance. The brain analyzes information from the ears to maintain the body's sense of balance.
Oh, I thought ears were just for hearing sounds.
Well, it's understandable that you didn't know. But haven't you heard of the semicircular canals before? Actually, the semicircular canals are located deep inside the ear.
Oh, really? I didn't know that.
The semicircular canals are, as the name suggests, organs formed by three semicircular, and the semicircular canals detect the direction of body rotation.
How do they detect the direction of rotation?
Inside the three tubes that make up the semicircular canals, there is a fluid called endolymph. When the body rotates, the endolymph also rotates in the same direction. From the direction of this flow, we can determine the direction in which the body is rotating.
I see.
And the semicircular canals determine the direction in which the lymphatic fluid is flowing, allowing the body to perceive its rotational movement. Even if the body is not actually rotating, if the lymphatic fluid is circulating, the brain mistakenly recognizes it as rotational movement.
Does that really happen?
Actually, the sensation of dizziness occurs precisely when this phenomenon occurs. If you keep rotating your body continuously, a vortex will form in the lymphatic fluid. This vortex doesn't disappear immediately. Even if you stop rotating your body, it continues. Just like when you turn off the power of a washing machine while it's still washing, the water inside continues to move for a while, right? In the same way, once a vortex is formed, it follows inertia and doesn't disappear for a certain period of time. That's why even if you stop rotating your body, the vestibular system still perceives rotation and an error occurs.
I see. One of the reasons why we feel dizzy is because the vortex in the lymphatic fluid of the vestibular system doesn't disappear for a while.
By the way, some people feel nauseous after the spinning stops, not during the actual rotation. This phenomenon can also be explained by an error in the vestibular system. When our body is spinning, other organs recognize that we are not actually rotating. However, the vestibular system in our brain mistakenly perceives that we are spinning. In other words, our brain simultaneously recognizes both the information that we are rotating and the information that we are not rotating. People who strongly feel this mismatch experience nausea and discomfort.
The feeling of dizziness when your eyes are spinning is caused by a sense of discomfort, right?
Yes, that's right. That's also why some people get motion sickness in VR. In the visual sense, the body may be moving vigorously, but the organs that sense balance, such as the vestibular system, perceive that there is no movement, causing this discrepancy, which leads to motion sickness. By the way, motion sickness in cars is also largely caused by this sense of discomfort. Have you noticed that motion sickness tends to occur when reading or looking at your smartphone That's because even though the scenery is not moving in our field of vision, our body senses that it is moving. And that discrepancy causes the feeling of discomfort.
The dizziness we feel towards various things can be explained as a sense of discomfort. By the way, besides the ears, there is also a reason in the brain for the feeling of dizziness, right?
That's correct. The brain analyzes the information from our field of vision, and the state of dizziness can be seen as a result of the confusion in that analysis system.
I wonder why the analysis system is in chaos.
When you keep rotating your body, the scenery you see moves at an incredible speed. As a result, the brain tries to chase after that scenery, but the speed at which the scenery moves is too fast. Unable to keep up, the brain becomes confused. And then the eyes start to twitch.
Wait, so when your eyes are spinning, they're actually twitching?
Yes, that's right. The state of your eyes spinning is the same as what I explained about the vestibular system, where the brain feels a sense of discomfort. And when we say that the eyes are twitching, it means that both eyes or one of the eyes are twitching at the same time. I understand that it might be difficult to grasp the sensation when we talk about the eyes twitching, but I think you would understand if you actually looked into the eyes of someone whose eyes are spinning. The eyes of someone whose eyes are spinning move rapidly up, down, left, and right.
I haven't really had the opportunity to closely observe someone whose eyes are spinning, so I can't quite picture it. So they are in that state. By the way, figure skaters chase after the scenery by moving their eyes at high speed. I heard there's a way to avoid getting dizzy.
Oliver, that's just a rumor.
Oh, really?
I've heard that kind of talk before, but it seems to be incorrect. As a tip to not get dizzy in figure skating, try to keep your pupils as still as possible. There's a recommended method for that, which is to fixate the position of your pupils. Moving your eyes rapidly is the exact opposite of what you should do. In other words, if you move your eyes too much, it actually makes you more prone to dizziness.
Then why don't figure skaters get dizzy?
There are two main reasons for that. One reason is because of the training we talked about earlier, where we try to keep our pupils as still as possible. Normally, when humans rotate, our eyes are programmed to move along with it. I'm training to resist this system. When your eyes are drawn to a certain point by the rotation, they return to their original position. The loop of being drawn into rotation and my eyes moving starts again. This loop is one of the causes of eye twitching. Figure skaters train to minimize eye movement and acquire a body that is less prone to dizziness.
So, they train to minimize eye movement because it can cause spasms.
And the second reason is simply getting used to it. The feeling of discomfort is caused by the difference between the actual scenery and the recognition of the vestibular system when the eyes are spinning. And this discomfort can be eliminated through training. To be more specific, if we keep spinning until we feel dizzy, our brain starts to recognize the discrepancy between the actual scenery and the condition of our semicircular canals after spinning as something natural that doesn't require any particular caution.
But I think there are people who don't get dizzy even without practicing, like after spinning or playing with VR. So isn't it possible that figure skaters are just naturally less prone to dizziness?
I do believe that there are inherent differences, but there's an interesting experiment that suggests we can train ourselves to resist dizziness. Oliver, you know people who don't get dizzy easily, right? They don't get dizzy whether they spin right or left, do they?
Yeah, it's not like they're stronger in one direction of rotation. They seem to be strong in both.
In this experiment, figure skaters were asked to sit on a rotating chair. First, they were asked to sit on a chair rotating in the right direction, the same direction they usually spin during figure skating, for 5 minutes. If a regular person were to spin for 5 minutes, they'd get dizzy and wouldn't be able to stand. But these figure skaters were able to stand up and walk calmly.
You're definitely a figure skater, huh?
On the other hand, when sitting in a chair that spins in the opposite direction than usual, rotating to the left, like a regular person, I ended up feeling dizzy. This figure skater has repeatedly experienced spinning to the right and has become strong at spinning to the right, but isn't used to spinning to the left, so they're weak at it.
So they're weak at spinning in the opposite direction. So if you want to make a figure skater dizzy, all you have to do is make them spin in the opposite direction than usual.
Well, that's how it turns out. From this experiment, we can see that training makes it less likely for your head to spin. By the way, there have been studies showing that if ordinary people spin around multiple times, they can also develop resistance to dizziness. So it has been proven that you can build up resistance through training.
Oh, really? But since we don't normally spin around in our daily lives, I don't think there's a need to train for it.
Well, when it comes to spinning, you're right. I think it's worth learning strategies to avoid getting dizzy because they can also be used for motion sickness.
I see. One of the causes of dizziness is the discrepancy between what we see and what we feel, and it seems that this applies to both VR and motion sickness. But based on the flow of our conversation so far, It seems like the discussion is heading towards getting used to riding in a car as a way to prevent motion sickness.
No, you don't need to worry about that. There are proper measures to efficiently increase tolerance against motion sickness. I believe people who get car sick, even if they increase the number of times they ride in a car, find it hard to overcome motion sickness. This is because they feel anxious about getting car sick. In fact, many people who are prone to car sickness have negative experiences associated with riding in a car, like getting scolded by their parents for vomiting in the car when they were little. A lot of people end up with a negative image of riding in a car. If you can eliminate this negative image, you can become resistant to motion sickness.
I see. But how can we overcome this negative image?
It's not something that can be resolved instantly, but by accumulating small experiences of success, we can gradually overcome it. Specifically, we can try to eliminate the causes of motion sickness as much as possible, and when we feel nauseous, take a break immediately before getting back in the car. If the smell of the car bothers you, you can ventilate it frequently and try not to get too hungry or too full. It would be a good idea to have a balanced meal beforehand and ask the driver to drive smoothly. By taking these precautions and ensuring that there are opportunities for rest in case of feeling nauseous, I believe we can feel relatively at ease when getting in the car. Once we develop a sense of comfort and confidence, the probability of experiencing motion sickness will significantly decrease. I understand that it might be challenging to implement all of these measures, but if we can gain the confidence of not getting car sick even once, it will be a lifelong benefit, so I think it's worth giving it a try.
When I think about how the unpleasant feeling I get every time I ride in a car could disappear, it seems worth doing. Thank you, Emma. I learned a lot again this time.
You're welcome. So here's the summary for this time. The mechanism of feeling dizzy happens when there's an error in the semicircular canals, which control our sense of balance and in the brain. The semicircular canals determine the rotation of our body based on the movement of the lymph fluid inside. If you keep rotating your body, the lymph fluid in the semicircular canals starts to swirl, and even after you stop rotating, the lymph fluid continues to move for a while. So even though your body isn't actually rotating, you might feel as if it is, and this discrepancy causes you to feel dizzy. You can get used to this feeling through training. The reason why you feel dizzy when you keep rotating isn't just due to the semicircular canals, but also because errors occur in the brain, which is another aspect to consider. When you rotate your body, the scenery moves at an incredible speed, and in an attempt to keep up with that movement, my eyes move on their own, and at the same time, my brain desperately tries to analyze the scenery. However, in reality, I can't keep up with the movement of the scenery, and as a result, my brain gets confused, causing my eyes to spin. But by training to fix the position of the pupil, you can develop resistance to this.
I understand.
That's all for this time. Thank you for listening until the end. I will continue to explain everyday questions like this. So if you're interested, please come and visit again. Well then.
Thank you for watching.
Thank you for watching.